Okay, so if you were going to pick, how many of you would pick out of these 6 dogs? Little happy jumping dog with frisbee. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many of you would choose this one? Dog with yellow collar. 1, 2, 3, 4, 5, 6, 7. Okay. How many of you are choosing very pettable fuzzy dog?
That's a girl.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. How many of you are choosing lab? Lots of labs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, and how about little dog with hat? 1, 2, 3, 4, 5. Okay. So it looks like we already did. Oh wait, at the beginning of the hour, I asked about that. And like everybody raised their hand. So raise your hand for that one if you don't have to. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 26 kids. All right. So bottom line is it's going to be Husky, and ooh, it's a tie for third. Lab, and then these two. All right. Final answer, do you want Spaniel or Frisbee?
Spaniel.
Who's going with Spaniel? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I said it wrong. I said Spaniel and I circled Frisbee. Okay, so Spaniel. Raise your hand for Spaniel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And who wants Frisbee? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, so Spaniel comes in. So who had all 3 of the winners from the start? Ooh, quite a few of you. Okay. Then, bottom line, what was the probability you were going to be right? Well, how many different combos are there? Well, how do we figure that out? It's a C for combination, right? Because combinations, the order doesn't matter. And there were 6 of them to choose from, and I wanted 3. You should know 2 ways to do that. You should know how to do it by hand with the little exclamation thingy bobs. It's called factorials. And you also should know how to do it with a calculator. I want you to do it by hand first. Then check yourself with the calculator. All right, just a reminder how that works. I'm going to give you the general formula, which doesn't tell you the answer, but it tells you how to get it. N minus R factorial. And then there's an extra R factorial. Nope. Yeah, an extra R factorial on the bottom. That's for any C problem. Now your calculator can do that too, probably a little faster, but you need to know what it's doing. And if you and your calculator disagree, it doesn't mean your calculator's for sure right. Maybe you're typing it in on the calculator wrong, but how many of you have a 2-digit answer that starts with a very small number? Okay, good. So then you should have said 6 factorial over 6 minus 3 is 3 factorial, and another R, which is 3 factorial. That makes 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 and another 3 times 2 times 1. That cancels that. 3 times 2 is 6 times 1 is 6. Cancels the 6. 5 times 4 is 20. Raise your hand if you had 20 for your answer. You are correct. Good job. Okay. That was a C problem. Why? Because it wasn't a P. The order didn't matter. On a permutation, the order would matter. All right, one little notation thing. You've seen this now enough times, but this is another way they could write combination. We don't use that way very often, but N is how many you have to pick from, and R is how many you actually picked. All right, so there's another way you could write that. Moving on. Remember, when you're trying to solve a problem, you ask yourself, does the order matter? And if it matters, it's a permutation. And if it doesn't matter, it's a combination. On the permutations, you can use blanks. Sometimes those are handy. Sometimes they're the only way you can do the problem, is with blanks. Like, for instance, if things repeat, like license plates where you can have FFF, when things repeat, you can't use permutations. You got to use blanks. You actually can use permutations, but it's more complicated. Yes? Okay, so numbers can obviously repeat. Somebody told me that they also saw a 666 on a license plate. So they can also repeat. I thought the 666 was like taken out of the list. I think that if you complain to the DMV and you say, I want a different number because of religious reasons or whatever, they'll work with you on that. If you're Chinese, do you know what number you really don't want? There's a really unlucky number, means death. 4. 4. And how about what do you want if you're Chinese? 8. A boy. Good. Yes, Chinese can only have one per child, so therefore they would choose, usually they choose a boy because then it carries on the family name. Okay, anyway, the Chinese lucky number is 8 is what I was trying to get at. Okay, moving on. Everybody get to this one. When should you use combinations or permutations? Shh. Here's some keywords to look for. Committee, that's always a combination. If it's any kind of a race, I would add that underneath this list. If it's any kind of a race, it's a permutation, because then the order matters. First place, second place, third place, order's mattering. If I'm going to just pick 3 of you because you're nice kids, then that doesn't mean I've chosen my committee based on 1, 2, and 3. It just means I picked 3 kids. So it's important to understand when to use order mattering and when not. If you go order a burrito at Chipotle and you say, I want the beans. No, put the rice on first and then the beans. They're going to be like, what, man? It's all going to get mixed together anyway. The order doesn't matter. Okay, fine. If you're some of you actually will actually have a way you want, because I actually do. I usually like to put the cheese, and I'd rather have them put the meat on top of the cheese, because then the cheese gets melted better. But I know, it's all going to get melted anyway. So that's the point. I don't go to Chipotle and say, hey, this is the order I want you to put it on, or they'll like throw beans at you or something. Yes? Say again? That's a good point. Usually if you put the shell on last, it probably gets really messy. I'll give you that. Yes? I've never had the guys at Subway be real particular about what order you put the toppings on. But you seriously order the ranch before the Chipotle sauce? Aren't they going to get mixed together? All right. So there's always somebody. In fact, there's a movie called When Harry Met Sally. I don't know if you've seen that, but the lady in When Harry Met Sally, she orders her food, and she always does this intricate, like, how she wants her food ordered, and if it isn't that way, it's going to be, like, a big deal. So, anyway, then the reason that's kind of funny is because most people don't do that. They don't care what order it comes out. All right, anyway. If you were able to choose any toppings, by the way, there are 11, to save you some time, would you please figure out how many different burritos they could make that have 2 different toppings? You can just grab your calculator and go right to that. If you know the right series of buttons to push. And just in case you don't, I want to show you. So there's 11. And I get to choose, where is that, by the way? Math, and then what? Probability. You arrow over to PRB. And then you find the C one. Why not the P one? Because order didn't matter. So I want the 3. 11, C, 2. I hit enter, and this is 55. All right, moving on. How many burritos going to make a 3? Come on, it's just 11C3. Too easy. Moving on. At the Price family reunion every year, a group of 3 is chosen to plan next year's reunion. There's 9 people in attendance this year, including last year's committee. How many ways can next year's committee be chosen from those present if a person cannot serve 2 years in a row. In other words, if you did all the work to plan the reunion this year, you shouldn't have to plan it next year. So then we really don't have 9 to choose from, do we? We have 6 to choose from. Choose 3, and that's all there is to it. Moving on. This is where they get more complicated, so you might want to start paying attention. All right, a bag of cookies has 6 chocolate chip, 5 peanut butter, and 1 oatmeal. So instead of just having a total of 11 cookies, or 12 actually, sorry, 12 cookies, it's not that simple. You can't just say 12, choose 2. It would not give you the right answer. Because we want to know about 2 chocolate chip cookies. All right. Well then, if I'm just picking from the chocolate chip cookies, how many of them are there? 6. And then, do we do a C or a P? C, because the order doesn't matter. And then, last, 2. What about the other cookies?
Just chocolate chip. Oh, so it's like given almost.
All right. It's kind of like given. Yeah. All right. It didn't. All right. So now, if I wanted to just, that is not the final answer, because that's a number. Probabilities are like point something, right? So is this 6C2 important? Yes, but it's not the whole answer. Remember, probabilities are always what you want over what? What's possible. Okay, so it's what you want over what's possible. That's what I want. What are all the things that could happen? The things that are possible. It's a C thing. Come on, you can do this. Isn't there a total of 12 things I could pick? And I'm going to pick out 2 of them, right? So there's my answer. All right, so if you actually take the top divided by the bottom, would you do that, please, right now? Use your calculator. And see if you don't get 0.23. I hope you do. If you don't, then you don't know how to type it right. Do this. Okay, so for this next part, you need to try to figure out the probability of getting 1 chocolate chip and 1 peanut butter. Somehow that's got to still be out of 12, choose 2, but I'm not going to tell you what to put on the top, and we'll see if you can figure that out. All right, so we need 2 C's on top, 1 for the chocolate chips and 1 for the peanut butter. Now just tell me, how many chocolate chip cookies were there to choose from? 6. How many did I want? See how that's 6, choose 1? You get that? Times by how many peanut butter cookies were there to choose from? 5, and I choose 1. And now, if you really want to get fancy, you can include one more thing, and this is not necessary, but do you get how there was only 1 kind of cookie left, and I chose 0 of them? Now, the only reason I do that is because now this plus this plus this adds up to this, and this plus this plus this adds up to this. And now it kind of balances it out. And if you do it this way, you can't get these wrong. It'll tell you if it's not adding up to the right thing. Do you get what I'm saying? If all the black ones have to add up to 12 and all the blue ones I circled add up to 2, you know you did it right. All right, so when you actually multiply all that out, you get 0.45. And the average of the class was pretty close. All right, so we had like 10, 12 kids that figured it out. Good job. 7, 10? Okay. Excuse me. Thank you for your time today. All right. Let's talk about a deck of cards. Okay, pause just 1 second. So the question was, why do I do the 1C0 at the end? You do not have to do this. You know what that comes out to be? 1. So if I times it by 1, it won't really change the answer. But why did I do that? Because now my numbers will actually add up to the right things. The black ones will add up to 12. If I didn't do this, it wouldn't have added up to 12. All right, let's move on to card questions. Find the number of 52 card hands that can be dealt. All right, so if I got 52 cards in the deck and I give you 5, do you get that there's a lot of different combinations you could have? In fact, let's figure out how many. Use your calculator. How many different hands could I possibly give you? There's a lot. Nope. It's in the millions. All right, there we go. And hopefully what you did is 52, choose 5. If you did a P by accident, then you saying and a number that's even bigger, and that's if the order you get them in matters. But in card problems, the way we assume here is probably like you play at home, where you deal out a bunch of cards to people, and then they pick up the pile all at once and look at their cards. So it doesn't matter if they got this card before that card. You got them all up. We pick them all up at once, so the order doesn't matter. That's why we're using C's. All right, next thing. Find the number of 5 card hands with 4 hearts and 1 diamond. All right, so here's how you do that. You got hearts, you got diamonds. You got 2 different C's on top. All right, and this isn't even a probability. I'm sorry, so we don't even need the bottom. Yes, you can do the C's on your calculator. So 4 hearts and 5 diamonds. How many hearts are there out there? 13. 13, choose 4. And how many diamonds are out there? 13, choosing 1. Now this isn't a probability yet, it's just a total number of cards. So what is 13 choose 4 times 13 choose 1? I hope you got 9,295. Did you do that right? If you didn't, then you might want to type it in again. You got 13, the C, 4, times 13, C1 equals. You should get 9295. Anybody verify that that's right? So make sure I'm not screwing it up somehow. Okay, good. Yes, ma'am. Because it is not a probability question. Notice the question says find the number of hands. There are 9,000 different hands you could get. It's not a probability yet. Now if they asked what's the probability you'll get that hand, then you would have divided by 52 choose 5. Because then that's all the possible hands, and these are the ones you want. Okay? But it wasn't a probability question. That's why it's not dividing. All right, next thing. Find the number of 5 card hands with exactly 2 queens. All right, so, 5 card hands with exactly 2 queens. This one, the teacher, when they did it, made a mistake. Let's see if you can be smarter than the teacher. The number of 5 card hands. Notice it's not a probability. Nope. It says find the number of hands. So you're not dividing by anything. Try it. All right, so there's 2 C's, right? I know some of you got this wrong right now because you just put in 1 C. You were like, oh, 2 queens. Some of you probably said, oh, there's 13 queens in the deck and I choose 2. There's like 10 things wrong with that. First of all, there's not 13 queens in the deck. What is there? There's 4. Okay, so there should be a 4. And if you just put this, then that would be wrong too. Because yes, there's 4 queens in the deck and you want to choose 2. But if you are going to get 5 cards, do you see you don't have 5 cards yet? Ah. Times by what now? Another C, and these are things that are not queens, right? How many things? Stop talking, please. 40 some hands. How many? 48 different cards are not queens, and I want how many of them?
0.
Nope. I have 5 cards with 2. Yes, I am recording. That means 3 that are not queens. Do you get how if I just stopped here, I would have only talked about getting 2 queens and not 3 other cards? All right. And this gives me my other 3 cards. That's why you'd multiply those together. Did anybody know that before I told them? Good job. A couple people. Way to go. I believe you. And there it is. 109,776. 103? Uh-oh. Would you double check that, please?
I got
103,776?
Yeah.
All right. Dang. Sorry about that. Okay. I thought it was 109. Last hour we figured out that the answer was wrong, and then the kid told me, and they told me 109,776, and I believed them. So I should have done it myself on the calculator. All right. This one. For a standard deck of 52 cards, find the number of 5 cards hands with exactly 1 heart, 2 diamonds, and 1 spade. You getting the idea that we need a C for each one of these things? And does it say probability? No, so we're not dividing by anything. See if we can get this one. Something see something times something see something times something see something. And a lot of people are going to get this one wrong. Double check that you made sense. All right, here's what you should be thinking. Hearts. How many hearts are out there? 13. Choose how many? 1. This is for the hearts. Okay, and the next thing is diamonds. Let's multiply these things. Diamonds, 13 of them out there, and I choose 2. Spades. Harder to draw a spade. Sort of like that. And how many of them out there? 13, and I want 1. And that's where a lot of people make their mistake. Because you need to keep going. Why do I have to keep going? Because so far, we only have 1, 2, 3, 4 cards. Do you get you need 5 cards? So you need 1 more card. And that's the one kind of card that we haven't talked about, which is, what do you know? Clubs. Anything that's not hearts, diamonds, and spades, which happens to be clubs. And those clubs, they look kind of like that. 13 of them, and you're going to choose how many? 1. Because that way, now you've got 5 cards. That's very easy to forget that last part, isn't it? All right. Here's your homework. Oh, what was the answer? Good question. 171, 366? All right. Cool. So these C's problems are some of the harder ones on the test, and it seems like you got it pretty well. Some of you might be a little lost still. That's okay. You're going to learn it over the next day or two. And we don't have to really have this mastered until next Wednesday, which is when the test is. All right, so tonight's homework is this worksheet, worksheet 12.6a, and you definitely can use your calculator on there. And that's all for our recording.